When the James Webb Space Telescope directed its keen eye at the faraway object Oumuamua, scientists and space buffs worldwide waited with bated breath. For years, this odd interstellar visitor had evaded complete comprehension, having shot through the solar system in 2017 with a form and motion all its own, unlike any asteroid or comet. Theories abounded, from icy body to extraterrestrial relic, yet the enigma remained. But thanks to the Webb telescope's advanced powers, humanity has finally received its first actual picture of Oumuamua. A picture not distorted by constraint, not reconstructed from conjecture, but one that looks directly into the very heart of the unknown. And what the telescope showed us is nothing short of remarkable. The object appears as a narrow, elongated thing moving across the vastness of space, its length many times its breadth, giving it that unmistakably cigar-like shape. Its surface is cold and dull and scatters sunlight in a way that looks phenomenally unnatural, as if the light itself were being filtered through some sort of intangible screen. In contrast to normal asteroids, which are usually tumbling, roughly shaped boulders with jagged points and wild rotations, this object has a remarkably steady orientation. It moves with the elegance of something purposeful, unwhipped helter-skelter by the power of space. This steadiness suggests an internal equilibrium, maybe even an inner design. From its reddish color to its non-uniform symmetry along its long axis, Webb's look pierces through decades of speculation. There are no craters, pockmarks, and breaks that mar most natural bodies. The reflections change subtly as the body turns, implying surface material whose behavior with light has never been previously recorded in a natural interstellar object. For the first time, astronomers are able to observe details too small to have been resolved previously. No ghostly tail streaming behind it, no jet of vapor spewing into the black, a typical sign of comets. It doesn't lose dust or debris. Rather, the shape is monolithic with areas of differing reflectivity indicating difference of surface composition. One hemisphere gleams dimly with a metal-like sheen that implies the existence of very reflective alloys, and the other is darker, with a matte finish that could be porous or carbonaceous. The most enigmatic aspect of all is the thin, band-like striations running along its middle. These are not cracks or shadows, they are ridges or grooves, sharp and smooth, as if cut into it. They curl around the object in uniformly spaced patterns, unattributable to chance erosion or random impacts. The James Webb Space Telescope wasn't constructed with Oumuamua in mind. It was constructed to peer into the distant past, to observe the first galaxies, the formation of stars, and the most feeble murmurs of light from the beginning of the universe. But its infrared sensitivity, unparalleled in any other instrument, was perfect for recording this fleeting visitor with previously unseen detail. Following it was not easy. Oumuamua is already well past Neptune's orbit, traveling at breakneck velocities. Webb's accurate pointing systems and ability to snap pictures quickly were strained to the maximum as it recorded frame after frame, each with a slice more information than the last. Those frames, merged together, created a portrait that pulled back the shroud of doubt. Each pixel contained clues, small differences in color, texture, and brightness that collectively started to reveal the object's narrative. The rotation information is the most astonishing of all. Earth-based telescopes, using brightness changes, initially indicated a turbulent tumble, as though Oumuamua was tumbling asymmetrically in every direction. Webb's high-resolution imaging paints a different picture. The rotation is systematic, almost calculating, with a fixed axis and a weak precessional wobble that recurs in a quantifiable cycle. This type of equilibrium is uncommon among natural objects, especially those which have experienced the violent birth throes of interstellar ejection. To sustain such a motion for billions or even millions of years would take a nearly perfect equalization of mass, the sort that nature only does by unlikely chance, or by design. Infrared temperature mapping casts more mystery. Heat distribution on its surface is lopsided in a manner that resists the simple explanation of solar heating. One side warms in excess of what is expected, even when it moves into shadow. This heat is not excessive, but it is consistent, hinting at internal retention or production of heat. Natural causes, such as trapped radioactive material or extremely insulating material, are plausible, but neither would explain uniformity seen. The warm face is too well delineated, nearly as though Oumuamua is actively controlling its thermal condition, retaining heat more in the fashion of constructed insulation than of a simple rock lost in space. The spectrographic analysis Webb performed may prove to be the most significant clue of all. The object's composition is complex. There are silicate minerals and organic compounds, much as you'd find in asteroids, but also elements in ratios and purities that do not match known solar system bodies. In some areas, the surface has an ultra-thin metal coating, reflecting but transparent in some wavelengths, like the films deposited by vapor for use on precision optics or heat control surfaces on satellites. In others, light behaves as if it were passing through microlayered structure, nearly like advanced lens coatings. The purity, uniformity, and distribution of such coatings push to the limits what can be attributed to natural processes. If natural, then Oumuamua could be something never seen before, a piece of the crust of a planet crystallized in some exotic environment, or maybe the skeletal remains of a destroyed ice giant that lost its atmosphere in a catastrophe. If artificial, then perhaps it is a hulk, an old probe, or the remains of something whose purpose is long forgotten. The Webb photo doesn't show antennas, thrusters, or any apparent machinery. But it also strongly resists being labeled as lifeless shard of rock. The enigma is further compounded by thinking about its path. When Oumuamua initially crossed through the solar system, its course was measured with accuracy. But there was something amiss. It was speeding up ever so slightly, in a manner that couldn't be accounted for by gravity. The easiest suspect, comet-like outgassing, was contradicted by observations. Webb's close look verifies it. No vents, no jets, no surface fissures suggesting volatile release. The object's trajectory in space seems self-propelled in some tiny, inexplicable manner, or affected by an unseen force we have not yet discovered. More intriguing still is its pristine state. Interstellar space is not vacant. Dust grains and micrometeoroids are hitting objects constantly, wearing them down over time. The majority of well-traveled rocks are pitted, scarred, and dulled. Oumuamua, however, appears pristine. Its edges are smooth, its surface unscathed, its reflective coatings, whatever they are, surprisingly intact. This implies either youth, i.e., it hasn't come as far or for as long as previously considered, or protection, possibly in the form of self-healing materials or an erosion-resistant coating. The starting point might provide additional information. By reversing its incoming path, astronomers have provisionally associated it with a red dwarf system some 300 light-years distant, a part of the universe packed with planets and subject to gravitational disturbances that might eject objects into interstellar space. The starlight spectra reflected off its surface align with stars in that vicinity, supporting this theory. But its vector of approach was peculiar, arriving at an angle not consistent with the overall stream of stars in our galactic locality. That would indicate that it potentially was intentionally sent, or at least expelled in a non-random fashion. In the Webb images, researchers also detected faint, periodic pulses of infrared radiation. Weak enough to not qualify as intelligible communication signals, but regular enough to not be ignored, these pulses recur approximately every 27 hours. They could be the result of some internal mechanical process, a resonant oscillation, or thermal vibration. Or they could be something entirely different. The trend is not matched by known natural phenomena in such bodies, but neither does it conclusively indicate artificial origin. Isolated, any one of them might be discounted. In combination, they create a profile unmatched by any previously encountered interstellar object. Its solitude is striking. There are no shards, no dust cloud, no trailing or leading companions. It moves alone, as if by design or happenstance. If it was once attached to a larger body, the separation must have been clean, with no remnants left behind. If it was sent purposefully, it is quiet, its sole action to slide by our sun before vanishing again into the emptiness. The image Webb brought back is not merely a picture, it's a breakthrough. For generations, we've been searching the heavens for signals, for messages, for proof that we are not alone. And yet, maybe the first true answer is not in a message but in an object. Not speaking, not flashing a hello, but merely sitting out there in a form that compels us to question the edge between the natural and the man-made. Throughout the scientific community, the controversy has sparked anew. Astrophysicists scrutinize each pixel, comparing and measuring, attempting to align the information with established models. Engineers analyze the surface textures, asking if they could make spacecraft as resistant. Futurists and philosophers ponder the very nature of discovery itself, how it would feel to discover something familiar yet strange, passive yet evocative. Oumuamua, caught at last in Webb's unparalleled clarity, is more than a mathematical oddity of 2017. It has shape and texture and color. It has an identity, not in terms of place of origin or intention, but in the way it engages the human mind. We can never come closer. It is already departing into the deep, carrying its secrets with it. But the instant of beholding it as it really is will be held, locked in the digital record of Webb's cameras and in the mind of all who gaze upon it. And perhaps that is the abiding gift of this photograph, not knowledge, but awe. The type of awe that compels us to create new telescopes, to peer into the dark more intently, to observe the faint motions at the fringe of what we understand. Somewhere out there, additional Oumuamuas could be passing, each heavy with their unseen tales. Now, we have evidence that if one comes close enough, we can observe it, not as a blur, not as the imagination of an artist, but as it actually appears. And when we do, we will be prepared to pose the toughest questions, even if the answers are still beyond us.